Hello everyone, welcome back to Newton Nuts. In today's video, we are going to solve the question 11 from Edexcel International ALL Physics Unit 1 paper. This question tests your understanding of Newton's second law and how to calculate the acceleration when both driving and resistive forces are acting on an object. So let's get started. Yeah, so we shall dive into the question. So while reading the question, as in the previous questions, we shall sketch a diagram. A lorry has a mass of 4,500 kilograms. Now this is the lorry. And I'll consider that the lorry moves into this direction. A forward force on the lorry is 6,700 Newton. That means there is a force of 6,700 Newton into the direction of motion of the lorry. The total resistive force acting on the lorry is 900 Newton. So you know that the resistive forces always acts opposite to the direction of motion. Now in this diagram the lorry moves towards right, so the resistive forces should act towards left, that is 900 Newton. Calculate the acceleration of the lorry. So definitely we have to go with the Newton's second law. So we have to use the equation F equals ma to solve this problem. So in this equation, F means the resultant force. M is the mass measured in kilogram and A is the acceleration. So in this case, there is you know that the forces are acting into opposite directions, so the resultant force can be gained by the difference between these two forces. So the resultant force here might be 6,700 minus 900 is equal to mass. Mass is 4,500 kilogram into acceleration. So we shall solve this one. 6,700 minus 900 over 4,500 is the acceleration. So the acceleration might be 1.29 meter per second square. Yeah, so we shall discuss some exam tips here. So a common mistake in questions like this is to use the driving force as 6,700 newtons directly in the equation F equals ma. But in this equation F equals ma, F is the resultant force. So you have to always check whether there are opposing forces acting on the object. Newton's second law always requires resultant force, which is the net force acting on the object. If you found this video helpful, please give it a thumbs up and subscribe the channel for more Edexcel and Cambridge physics past paper solutions. If you would like personalized one-to-one online physics lessons, I teach both Cambridge International and Edexcel physics students worldwide. You can book a lesson and learn more by visiting the website www.newtonnuts.com. Thank you for watching. I'll see you in the next physics lesson.
If this video made that light bulb go off in your head, do me a quick favor. Smash that like button and subscribe to the Newton Nuts channel. It really helps me keep creating these free lessons for you. Now, if you want to completely ace your upcoming exams and need a little extra support, I've got something special for you. Head over to www.newtonnuts.com right now. To make sure we are a perfect fit for your learning style, every single student gets a 30-minute, one-to-one free trial class before we officially begin. No strings attached, just 30 minutes of dedicated, personal physics help to kickstart your progress. Thanks for tuning in today. If you enjoyed this lesson, stay tuned. I'll see you in the next video with more exciting topics.